Hey guys, we're going to start our review with reviewing linear equations, okay? So that's any equation where there is a single variable and we're trying to isolate for that value. So when we look at a problem like this, there's a few things we need to keep in mind. The goal is to isolate the variable, okay? Now, to isolate the variable means to get it alone on one side of the equal sign. So we have to do whatever it takes to get that variable by itself. So we take a look at this question. What is the first thing that should bother us when we see this question? And that should be the parentheses where our x value is trapped inside, right? We have one x value on the outside, one x value on the inside. Somehow we're going to need to combine those. Okay, so when you look at a question like this, the first thing you want to do is distribute. Okay, we want to distribute to eliminate the parentheses so we can move on to the next step. Now, when we distribute, remember, the sign comes with it. So I'm going to distribute a -3 to both of these terms inside the parentheses. So I get 15x and minus 9x minus 12 is equal to 6. Now, please remember to distribute that negative. So now we're left with the second issue. We have two x's, right? We only need one. So our second step is going to be combine like terms, okay? And when I say combine like terms right now, I'm just meaning anything that is on the same side that has the same term. So 15x and minus 9x are like terms, and they combine to get 6x, okay? And so now our last thing we have to do is to isolate the variable. So we have to move things to the other side until we get x by itself, okay? So what am I always going to move first? Well, I always move my addition or subtraction first, which I do by using my inverse, right? Subtraction cancels with addition, and I get 18 on this side. And then I eliminate any multiplication or division. So I'm going to divide by 6 on both sides. That will cancel there, and I am left with 3 as my answer, okay? Now, you know you can check your answer at any point by plugging it into the equation. So 15 times 3 minus 3 times 3 times 3 plus 4. And when you plug that whole thing into your calculator, you should get 6 is equal to 6. Okay, so we're going to continue. We're going to take it up a notch with some fractions. Okay, so now the steps are going to be the same. We're still going to eliminate parentheses. We're still going to combine like terms, and we're still going to isolate the variable. We just want to make sure that we're taking care of our fraction. So when we see a question like this, right, one value outside of a parentheses, we have two options. The first option is we can eliminate the 7/3 first, or the second option is to distribute first. Both will give us the same answer, so I'm actually going to show you both cases, okay? So in the example where you want to eliminate 7/3 first, okay, we are allowed to do this because it is isolated on one side, right? There's nothing being added to the end. So I can always multiply by the reciprocal to eliminate that coefficient. Okay, that will cancel everything outside of our parentheses, bringing down just our parentheses. And on the other side, we get 60/7. Okay, so now what's left? Well, now I'm going to subtract 9/28 minus 9/28. Okay, this will cancel, and we get 60/7 minus 9/28. We get 8.25. If you press math, frac, we can turn this into a fraction as 33/4. Okay, so that is one method. The second method is to distribute first. So we're starting with the same 7/3 plus, okay? And in this example, I can distribute the 7/3 to both terms in my parentheses, just like I did in the question before. So that will give me 7/3 x plus 7/3 times 9/28. So now I could cancel, right? 7 and 28 will cancel with a 4 down here, giving me 9 over 12, which we should know reduces down to 3/4. Okay, and that's equal to 20. And I fix that. Okay, and from here, now we just have a simple two-step equation. Get rid of my addition, get rid of my multiplication. So subtract 3/4 from both sides. When I subtract 3/4 from both sides, I end up with 77 over 4. Now you could do that by making like denominators or just plugging it into your calculator. And then we have our final step of multiplying by a reciprocal to cancel out a fraction. Okay, so the 3's will cancel, the 7's will cancel. The 7, we get 11 over here. That's 33 over 4, which again, you can plug into your calculator. Gives you 8.25. So notice, no matter which method you use, you should get the same answer. Okay, let's try two more. Okay, I'm going to ask that you pause the video and give this one a chance. Okay, see if you know how to do this. So let's go through our checklist. Is there anything to distribute in this question? Are there any parentheses? And the answer is no. Okay, there's not. So we can move on to the next thing, which is combine like terms on the same side. So again, we have an x and a constant on the other side. There are no like terms, so we can move on. So the last thing is to isolate the variable, meaning we want all the terms with the variable on one side, all the other terms on the other side. So to do this, I'm going to move my constant to that side to cancel. So I get 3/4 x is equal to 5/4 x minus 8. And I'm going to subtract this x term to this side. Now again, it does not matter which side of the equal sign you isolate your x on, as long as you follow the inverse operations appropriately. Now this, when we subtract 3/4 minus 5/4, gives me a minus 2/4, which actually gives me a minus 1/2 x. Now, again, to get rid of the negative 1/2, I'm going to multiply by the reciprocal, which in this case is a negative 2. Remember, negatives follow you when you use a reciprocal. That will cancel everything on that side and give me a positive 16 as our solution. Okay, and so now let's try one more example just to make sure we really understand this. All right, so what's going on in this question? Well, we're kind of combining everything. We have multiple sets of parentheses, and we have things happening on the outside of the parentheses. So the steps are going to stay the same. We're still going to distribute first. And now since we have two sides of our equal sign, we can distribute in the same step on opposite sides of my equal sign. So I can distribute this 4 to these two terms to get 4x minus 28. And I can distribute this 0.3 to those two terms on that side. Okay, it does not matter that it's happening at the same time. Okay, so now what was the second step? The second step was to combine like terms. So on the left-hand side, there are no like terms, but on the right-hand side, I have 0.6 and 2.11. So I'm going to combine those like terms to get plus 2.71. Okay, and last but not least, isolate my variable. So I like to always move my constants to my right-hand side. Oops, plus on both. And my variables to my left-hand side, but again, it does not matter. I get plus 30.71, subtract 0.3x. I get 3.7x. Divide by 3.7, and I get 8.3. Okay, now again, remember, you can check this by plugging it in, but I'm actually going to give you a little trick for another way we can check our equations, okay, and it is using our calculator. All right, so now remember, we want a value that makes this side equal to that side. Okay, so if we look at those two sides as different equations, we can actually plug this into our calculators to find our answer. So how do I do that? Well, the first thing I'm going to do is I'm going to plug each side of my equation into its own y equals, okay? Thinking of them as two separate things. So I plugged in my left-hand side into y1 and my right-hand side into y2. Okay, so what does that do? That will graph the two lines separately. Okay, so what's next? Well, the second thing I'm going to do is I'm going to use my calculator. So I would look at the graph. You'll notice that they will intersect somewhere, right? It's that intersection point that is going to help us solve this question. So if I press second trace and choose option number 5, intersect, right? Just as I normally would with the systems of equations, press enter, 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 okay? We get a point of intersection at the bottom here. It is that x value that is going to be the answer. Notice x equals 8.3. X equals 0.83. So again, should not be the only way you solve equations, but it is a great quick check for equations, especially ones with a lot of steps. Okay, so that's just a little bit of help for solving equations by graphing.